Hi, and welcome to a demo of EasyML, the world's first transparent machine learning platform with the ability to predict outcomes from textual data. Most ML platforms, as you know, are opaque, not EasyML. I'll demonstrate how EasyML predicts and gives you deep insights into your data so transparently. In order to do the type of machine learning that EasyML performs for you, you would have to have a proficient understanding of data science and know how to program the lines of code required. EasyML lets you bypass all of that. The entire pipeline from start to finish takes the burden off of the user, you, for data cleansing, model building, optimizing parameters, and finding the best model. But don't let the name EasyML fool you. Under the facade of a user-friendly, easy-to-use platform lies a very sophisticated machine learning platform. It's also used by advanced users and data scientists. It gives you valuable data insights that no one else does. When you hear the term machine learning, prediction is what comes to mind. But the most important thing that machine learning provides is the data insights, explaining how the variable features are related to each other. EasyML is the only platform on the market that can provide these kinds of data insights in specific detail, and you'll see how. Please watch until the end. For illustration, I'm going to use a data set about the influence of various parameters on systolic blood pressure. Systolic blood pressure is an important parameter to measure a human's heart health. Blood pressure is influenced by a myriad of habits, such as amount of sleep, exercise, meditation, and so on. Maintaining a healthy systolic blood pressure level varies from person to person, depending on what your own body needs. EasyML can help you understand what factors most heavily influence systolic blood pressure in the average person in our training data set and help you predict what your blood pressure will be if given other factors. Please note that this dataset is used only for demonstration purposes. This is not to be taken in any means as personal health advice or guidance, and please consult your doctor before taking any kind of medical action. So going to easyml.com here, we can first easily create a personal account by clicking here and signing up. It's incredibly easy just to enter an email or password, or just do one-click login with Google. I already have an account, so I'll go ahead and log in. So let me show you some of the basic functionalities of the platform. You can toggle between dark and light mode depending on your choice. I'd also like to highlight the Help button here. If you're new to machine learning and EasyML, the Help button can be your guide and your teacher. It's not a static button. It'll actually tell you what EasyML is doing to your data at every single step. We can also go to advanced settings here if you're not a beginner, where you can configure parameters to your liking. You can enable or disable hyperparameter optimization, adjust perturbation threshold, and so on. EasyML, of course, is an AutoML platform, so again, no coding is required if you're using the GUI portal. However, EasyML does have APIs for advanced users and data scientists who would like to build their own machine learning pipeline. So right here, I'd like to emphasize the API endpoints that EasyML offers, including Easy Insert and Easy Fetch, allowing you to insert your own data frame into the EasyML pipeline or fetch a snapshot of the data frame at any point, along with a bunch of other API endpoints. So going back to the platform here, the first thing we'll do is select our mode. Selecting accelerated mode makes it as easy as possible with just a few clicks until you get your results. For the demo here, we're going to use detailed mode that'll take you through the entire flow step by step. You can absolutely override EasyML recommendations if you prefer to. EasyML is a smart ML platform with built-in checkpoints and guideposts, so for most use cases, you can trust and accept EasyML's default recommendations. We first upload our training data. So this here is the raw training data that we're going to upload. It takes into factors such as hours of sleep you got at night, what kind of food you've eaten throughout the day, the amount of exercise you've gotten throughout the day, the kind of medications or supplements that you've taken throughout the day, as well as factoring in how you feel, whether you have a cold or not, or maybe even COVID-19. And then it considers your systolic blood pressure. Normal is the best level. Okay is slightly higher than normal, with high being the least healthy blood pressure level. So right here is the training data that we've uploaded. EasyML has interpreted all of the data that we had in our raw Excel sheet that I just showed you. With this training data, we'll actually be able to predict systolic blood pressure, provided data about the various factors. So we'll continue to build our model to achieve this functionality. So if we had an ID column, we would identify it here. If you're confused about what any step means, I'd like to go ahead and emphasize the Help button. It'll explain the systems that are working to help you for your ease of use. And of course, if you still have any other questions, you can reach us at support@easyml.com. So right here, it's asking you to specify the identity variable in your data. If you don't know the ID variable, or maybe if you don't have an ID variable, we'll go ahead and select None and click Next to move forward. You can click on the Help button on any screen. We're not going to discard any columns. And right here, it reports all of the data types corresponding to the variables we've implemented. They all look right, so I'll go ahead and continue. These are the statistics corresponding to our variables. Asking if we want to remove any outliers. Again, we'll go ahead with the default, so yes. And it says there were no outliers present, so perfect. So right here is the process data. EasyML has converted all of the variables into an accepted data type. And we can go ahead and continue again. So sometimes training data can be clustered, and so we recommend shuffling the training data just to remove any ordering or dependency on order bias in the training data. The outcome variable we want to predict in the future is the systolic blood pressure, of course. And it shows you the results of our process data. It has 115 rows with 14 native predictors. We can also go ahead and visualize our data. So pretend I want to see how hours of sleep at night, along with the amount of exercise we got, influenced systolic pressure. So there are 3 levels of systolic pressure, normal, okay, and high. Of course, due to the nature of this data set, this visualization is not the most simple to view, but you can imagine how it would be extremely helpful for a number of data sets. So even if we just had a 2-dimensional visualization here, it goes ahead and categorizes how hours of sleep and minutes of aerobic exercise factored into an okay, normal, or high blood pressure. So now we're done with the first step. At any point in time, we can click the trace button and it will show you the last 5 screens. Or we can go ahead and show all of the screens if we want. This will help you learn what the platform is doing, or if you just wanted to review or remind yourself of something that happened, you can do that here. And we can exit trace and continue on. So of course we want to continue building our model. Since this data set is not dependent on time as a variable, we'll want to build a predictive model. So it's identified the type of problem we have. We're not going to remove dependent predictors or add numeric derived predictors. And right now, EasyML is going to select the features. So this is the data that it's building a model upon. It's the training data that we uploaded. And building a model could take anywhere from a minute or 2 to half an hour to a couple of hours. You can log out of EasyML or close the tab at any time, and it'll continue to build the model for you. Of course, if you have more lines of training data, it'll take a little bit longer to build a more accurate model. But like I said, you can leave at any time, and EasyML will continue to build the model in the background. EasyML is building many models in the background to find you the best fit for your data. EasyML will recommend to you the best performing model among the ones built. So here it gives us 9 models that it built along with the kappa and accuracy. So what are kappa and accuracy? Accuracy is exactly what it sounds like, calculating the ratio of correct predictions to total predictions. Kappa is a performance measure that shows you how much better your classifier is performing than a classifier that simply guesses at random according to the frequency of each data. So right here, the boosted decision trees with information gain had the highest kappa and accuracy, and so it's the best fitting model for our training data. And we'll continue with that one. So right here is our global variable importance chart. It shows you the global importance of the predictors. As we promised at the beginning, EasyML provides you insights into your data, telling you which of the predictors play a critical role in influencing your systolic pressure so that you can appreciate how your heart behaves. So we see that the most important factor here was work stress level, followed by minutes of exercise, followed by medication, and so on. So here we see that EasyML has given you training data bias detection. So EasyML has performed feature selection, removing the frivolous predictors and isolating the influential ones. Your training data led EasyML to come up with this list of influential predictors: work stress level, minutes of aerobic exercise, evening medication, and evening walk. If you understand why these predictors are influential and you feel that they're correct, then there's no bias. But if you feel that some of these should not influence the outcome, then it reflects a bias in your training data. This is a critical observation, which is incredibly important to the prediction accuracy of your model. So yes, these are influential as per my understanding. We'll go ahead and continue. So model is built. The only thing left to do is to use the model to predict on our test data. So we're going to use the best fitting model, and I'm going to upload our test data, which is in the exact same format right now. And again, it can detect bias in our training data like I just explained. Take an analogy, for example. Let's say you've been studying calculus all semester, but the midterm comes and the only questions on it are about molecular biology. Now, you wouldn't be testing very well or reporting what you know very accurately, would you? This is what the training data bias detection reports: whether the test data you fed it had a good representation in the training data and thereby in the model you built. There was no bias detected in our training data points. So right now it's predicting and it's ready. We can go ahead and see all of our predictions here. And we see that since the predictions are in green text, we know that it got them all correct. So right now we can understand our predictions. EasyML makes predictions, as do other platforms, but what if you have a question? What if you don't agree with a prediction or you don't understand a particular prediction and you want to know what the reasons were behind the prediction? You're curious. Other ML platforms don't explain their predictions, but EasyML does. In fact, it's the only ML platform that explains the reasons behind the prediction, and in the process, you may learn something new about how your heart behaves. It's incredibly powerful. So we can go ahead and explain the first prediction here. So for this first prediction, maybe you don't understand why your systolic blood pressure is high, even though you did aerobic exercise as recommended earlier by the system. In fact, the bar chart for important variables shows aerobic exercise as one of the most important variables. So why is there this dichotomy? EasyML will explain this to you. It identifies the rules in order of importance of why your systolic blood pressure is high even after you exercised. Look closely here, and you'll find that it states you exercised for 12 minutes, but that's not enough, as your heart requires at least 20 minutes of aerobic exercise before it decreases your systolic pressure. Now you know why your blood pressure is high, precisely, and you know what to do to keep your blood pressure in check in the future, which is invaluable information. So we can go ahead and understand predictions for every data point, if we please. but we're going to go ahead and look at my account, where I can see the training data sets that I've uploaded, the models built, the prediction data sets, activity, and usage. In the models, we can see here, this is the training data set that we just used, blood pressure training data, and it gives you statistics about the model, including configuration settings, all of the trace options, and the option to delete the model if we want. EasyML can be this accurate and helpful in any sort of everyday problem that you might run into. Be creative and try it for yourself. Share with us your results and findings on Twitter or Facebook. We would love to see what you did. Try EasyML for free today and learn ML by doing ML at www.easyml.com/personal. I want to conclude by reiterating how powerful yet easy to use of a platform EasyML is. It's truly transparent, traceable, and can detect and alert if your training data has any bias. No other platform is as transparent or easy to adopt as EasyML. Please don't hesitate to reach out and contact us at info@easyml.com. We promise to respond within 1 business day after you reach out. Thank you so much for watching, and we'll see you next time.